Hello and welcome to another Out of Spec Reviews video. You join me in Mesa, Arizona, where we got burnouts happening out of Model 3s over behind me. And I brought along my dad's Lucid Air that we just cannonballed New York to LA. And New invited us here to basically showcase a lot of work that they've been doing. It's also the celebration event of their rebranding, going from Atlas Motor Vehicles to New, because of course they're a full EV ecosystem company, not just a future truck manufacturer or anything. They're really getting into the charging space, the cell manufacturing, really everything that can go into an electric vehicle. It's pretty impressive. And well, I'm here to see their new prototype charger and of course plug the Lucid into it. So I arrived here at very low state of charge. We're gonna plug it into their new charger. We're gonna talk about where you might even find these out in the wild. And then we're gonna go on a little tour of how they're making their battery packs and a whole bunch of stuff. You guys know when we're here at New, it's nerd level 9000. That's not stopping at all. So let's not waste any more time. Let's get this thing plugged in and see how fast we can charge the Lucid Air. Victor, how's it going, sir?
How you doing, Kyle?
We are seeing again. Great to see you.
I noticed no sweater today. What's the occasion?
Well, I had one on, but it was a little too toasty out here.
Oh, come on.
So,
I'm wearing all black. It's not too bad.
Okay, I'll put it on.
Okay.
I'll put it on. What's going on here? What is this? Tell us what you have going.
As you know, we revealed earlier, formerly Atlas, today it's the New. It was the megawatt charger. We revealed we did 1.2 megawatts plus of charging, but at that time, that was the Atlas charger, and today we're here to introduce our CCS version of that charger. Currently, what we have installed is 700 plus kilowatts of charging capability. Unfortunately, it's very difficult to find vehicles that are capable of that high power rate, but we've done a lot of vehicles today, nonstop, vehicle after vehicle. And one thing I want to point out as we get closer, come check this out. This cable, this handle, tell me about it.
Well, okay. I just want to clarify something. You said this is a 700 kilowatt charger.
Rated for 700, rated. It can boost.
It can boost.
That.
So sometimes we're talking like a 50 kilowatt charger that can boost to like 75 or 100. This is 700 boosting to more.
Yes.
Holy crap.
So this cable right here is a 700 rated kilowatt cable. And do you notice you've been to the Huber Schuner cables at Electrify America sites?
Yes.
And the weight, tell me about the weight.
Okay, so my impression is this feels like a 175 amp cable, like in terms of equivalency. That's, bendable. Certainly it's warm out here, but it's a much thinner cable. There's no heavy weight up here at all.
Not
and
at
it's
all.
something you can just wiggle around. It feels like a version 2 supercharger.
One hand.
Yeah, absolutely, one hand, which is so needed because you know how many times I'm like trying to film and wrangle cables into cars.
I can relate.
Yeah, crazy. So how can this cable, none of this is rehearsed. How can this cable do this?
So we try to, one of the reasons we have this event is for us to understand how the vehicle works with the charger. And we're trying to test every vehicle on the market. And I got to say, knock on wood, we've been really successful here at New testing all the different vehicles. We have not tested a Lucid Air. So this is completely unscripted. First time we're plugging into this vehicle, and it's above an 800 volt architecture. Majority, 90% plus of the vehicles we've charged were on the 400 volt architecture. We charged Teslas. Behind there's a Mini Cooper. We've done a Rivian earlier. We did experiment with a Porsche Taycan yesterday, and now I'm excited to try this, the highest voltage architecture we've ever tried. Now, granted, in the last video, we did your Tesla Plaid at beyond 650 amps. And that was for a cable that was unrated for that.
We tried to fry the cable.
So I would love to see what we can do with this car and see what happens.
Well, that's going to be the big thing. So your event today is basically have members of the local community, electric vehicle associations, bring their cars by so you can do interoperability testing.
As well as our investors from the very beginning, and show that we're building products that are real. This is the most powerful charger that exists. Promise you that.
So
it's not a released version yet. A couple other things I want to point out.
Yes.
Is that, as you notice, once again, there's no screen on this.
Yeah, I was just about to ask about that. Is that a prototype thing, or what's going on with that?
Very similar to how others do it. The whole point is it's going to be a seamless experience. This particular prototype, once again, we're going to have a button for start and stop. But the whole ideal situation would be you plug in and you start delivering a charge. And then a customer would go on the website. I'm going to show you that once you start charging. You go on the website, you register, and it's going to ramp up the power depending on what you pay
that's
for.
perfect. So just like that Zusmarshausen site that we showed, you plug in and you trickle it. And that just at least gets the communications out of the way, gets the car starting to charge, you match your voltage, all that stuff. And then you access payment through either, will you have like a terminal somewhere,
A
or is it all
kiosk, if
online?
necessary,
Okay.
or ideally it would be on your cell phone.
Amazing.
And the whole point is about the user experience. I mean, how often do you go and you're trying to fiddle with the handle?
Yeah.
I drove to LA like a month ago and just watching the people struggle to use the chargers.
Every time you roll up to a charger, it's just confusion. Mass
is.
confusion.
My favorite is when a Chevy Bolt plugs into a 350 kilowatt charger when the 50 kilowatt, and my vehicle takes 150 kilowatts.
Yeah.
And I'm like, come on, like I have to trickle charge when your car is only taking 50.
Totally agree.
There's no compromise when it comes to this. So every station that you plug into, every port, you're always going to experience the fastest charge delivery possible. It's meant to be seamless. You don't have to think about, is the split charge? Am I going to have to figure out how to use it? You plug it in, it starts working.
So I have more questions about that, but let's do that plugging in thing and see how it goes. So first of all, we've done this a bunch because we just cannonballed this car. And
talk about it. What's the state of charge right now on the vehicle?
hold this. It's at 1%. Okay, so 1% state of charge. Car's locked. Let me get the key for it. 1% state of charge. It's warm out today. It's like 94 degrees or something like that. We drove it pretty gently. I preconditioned it for a while on the way over here, maybe about 20 minutes. But then again, it sat here and cooled down. So
I'm gonna put this back. I'm gonna leave it for you to pull out.
Okay, sounds great. So basically, cars should accept almost everything, but it's always hard to know because Lucid doesn't give you a temperature gauge like Porsche does. And we don't have access to the CAN systems on the car. So
you're gonna plug it in?
I'm gonna plug it in.
You're gonna push the button.
I plug it in, I hit that button.
That's it.
An explosion.
No explosion.
No explosion. Okay. So first of all, one-handed. Wow.
Oh, wow.
This is just, mind-blowing. It really is. Okay, we're going to go into the port here. We're
Push the
connected.
button.
I'm going to push this button. We are now going to take a look on the Lucid screen, and it says preparing to charge.
Oh my God, like it started. I heard the click.
So
There you
it
go.
says 4 miles of range.
And so what it does initially is it ramps up the charge. It doesn't instantaneously blow current into it. So
Okay.
every approximately 10 seconds, it's jumping 50 kilowatts at a time.
Oh, I
So
see.
I was talking about the app experience earlier, and I got a prototype version that I'm going to share with you here. And so I'm just loading up my screen. And I'm just going to block our internal IP. Oh,
Yeah.
my bad.
Okay, by
Okay.
the way, look, I just want to show you this, guys. We're already at
Here you go.
200 kilowatts.
Okay, check it out. Everything that you see in the vehicle, you should be
Yep.
able to see over here. So currently, 1% state of charge just started over here.
Yep.
The vehicle is currently at a 771 volts. That's what it's outputting right now, 77, 779, 277 amps being delivered, and it's peaked at, and on the bottom you can see over here, that's its peak amperage.
Right.
And then it's currently
Yep.
delivering 218 kilowatts.
That's exactly what
You
the
can
car
hear
is
the-
showing and ramping.
Is that the car? The
Yes.
car is roaring its HVAC
Yes.
right now.
It's possible the battery's just slightly warm because it's already kicking HVAC as soon as we plug in, but it's still, the car's not saying limited by station. The station's going to give it everything it can, so that's really sick.
You can just blur that out.
Yeah.
So if you just want to take a look, let's go in the shade so you can see it. And you can see right now it's 4% state of charge. So far it's delivered 3.5 kilowatt hour. 804 volts right now, and it's peaked at 804 volts. So on the bottom it's going to show what it's peaked at. And 279 amp peak and 219 kilowatts. It peaked at 224 kilowatts, and right now it's going down.
And it actually may ramp up here in a second.
I
So
would love to
typically
see it,
when I'm going to put it in percent, usually 5% is when it.
Let's do it.
So let's see what happens here. It shouldn't be long, but just to put it in. So now we're at 5% state of charge. I'm just going to turn climate control off. So it switched profiles and doing 214. AC compressors juicing real hard. May have had the battery a little warm.
Consistent though, right away 200.
Oh my gosh, if we had this on the Cannonball, we would have had the record time in.
Yeah, tell us what you want. I mean, seriously, put it in the comments where you like to see this type of infrastructure set up.
Well, talk about that a little bit
Yeah.
more. So this is mobile.
This particular version that we have is designed to be mobile. And so in terms of the mobile version, what it means is it's battery pack enabled. So it doesn't rely heavily on the utility. For example, inside, and I mentioned this before when we revealed the internal components of the system, there's very few components in terms of power delivery. The battery is going to take up approximately 50 to 75% of the capacity of the container, and that allows about 20 plus vehicles to be charged from that battery bank.
How big's the battery?
I
Yeah,
don't know if I can reveal that yet, but
okay,
the particular
but to
design.
do 20 vehicles, it has to be a sizable,
Yes.
more than we've ever seen
Yes.
from a battery-enabled.
It's going to be
system.
touching 1 megawatt hour within this particular container.
Okay,
I'm just going to say that.
Okay, that's
You can say that.
insane.
And so what's really important about that is you can literally take this container, it's portable, it's a standard 10-foot container,
Yeah.
and drop it anywhere that's necessary. If you don't hook it up to the grid,
Yeah.
20 vehicles from nearly empty to full,
Yeah.
and then it has to get recharged. Alternatively, you can trickle charge. So if you hook it up to the grid, take what you can from the grid and the duty cycle, depending how many vehicles
Can
show
you
up
do
at
an
the site.
AC grid connection?
Yes.
And so
I
you'll
thank you
have
for
an
bringing that up.
onboard charger.
And so it is a bi-directional power converter built into it. And
Oh,
so
cool.
it's designed that if the power ever goes out, or even energy as a service, which is
Yeah.
what we do here at NU,
Yeah.
is the ability to say, hey, your utility is peaking demand right now. Let's take care of that peak demand, that duck curve, as it's called in industry,
Sure.
and reduce the cost for the consumers because electricity is cheap during off-peak and it's more expensive during peak time. So let's send that energy back and feed it to be able to sustain the infrastructure.
This is so cool.
Yeah.
It's amazing. And
Charging.
so you can really, I mean, you could hook it up to anything. You could hook it up to a
Yes.
240 volt,
Yes.
NEMA 1450
Yes.
if you wanted to.
Yeah, it'd take a little bit longer.
Yeah, sure.
So that's 50 amps.
Yeah.
But yes, it can do that. The whole point is a universal solution to a universal problem.
Yeah.
And so all you hear is about range anxiety, you hear about infrastructure problems, and this really does solve all of that.
Can you just put it in Quartzsite
Yeah.
between here and LA? Because
You know what? I like that.
because you know that EA station has like a line 30 cars
I've been there.
deep.
I know.
Yeah. So
I know
like
exactly.
if you just have one of these and everyone's like in and out,
Yeah,
you can like solve the problems.
We would love to. And so part of the whole new ecosystem is to be able to own that infrastructure. So we're not just going to take the charger and drop it in a Carl's Jr. The whole point is you're going to have a seamless experience, kind of what I was alluding to earlier, that you're going to come up by, you can have covered sites. You're going to
cool.
show up in the sun or in the rain or in the snow
Yeah.
and be worried that you're going to be rained on while you're plugging in an electric vehicle. So you're going to have all those amenities as well as the convenience store. There is also no split sharing charging, meaning that if another vehicle pulls up, like I said, this charger is 700, someone else pulls up, they're also going to get 700 if they're capable.
And so explain that a little bit more because you have a limited number of charging power in one unit. But how many cables will you have coming out of one?
This particular model has one. The ideal station will be 2 ports, fully dedicated, full power, in a under 1 megawatt hour container.
So you can basically do 2 Hummer EVs full send.
I would love to.
Yeah.
Like I said, we're trying to charge every vehicle on the
Yeah.
market, and so far we've been pretty not impressed with the vehicles that have showed up. You
Yeah.
have broken the record today in terms of the most powerful charger, and for that, we're giving you the new sunshade.
Oh, that's right.
That we saw on the
Thank
front.
you. Appreciate that.
definitely
Yeah.
broke that record.
Okay.
So I'm very happy. First try, no problems. I was a little skeptical. Will it work? The high
Yeah.
voltage architecture.
Yeah. No, it just plugged in and ripped.
I'm happy it worked. Same thing with the Plaid. I was like, please work.
But that's the thing, if it didn't work, like our plan was, we didn't rehearse this.
No.
It was like, if it doesn't work, let's bring our viewers along how you would code it to actually accept it.
Yeah.
Now, and still, weird things may happen as this car gains voltage because we plugged in, we were at 770, you said?
Yes.
This is 924 full.
This has no problem up to 1,000.
Right, so we'll
I'm
see.
not worried.
Yeah, but if it does,
No,
it'll
if it's
be
working,
interesting.
no,
Yeah.
it's like flying an airplane is easy. It's the landing that's hard. For this,
Okay.
you start the charge. I'm not worried about the
Okay,
rest.
nice.
As
very
long as
cool.
the charge starts, everything's
Then we're
easy.
good. So,
Let's see. Let's.
How are we still doing in here? So we're down a little bit. We're down to like 200 kilowatts at 17%, which is not too far off what the car can do under peak conditions.
Yeah. So let's take a look right now. So 17%. We've delivered 20.8 kilowatt hours in 6 minutes. 830 volts currently, and that's peak voltage that the vehicle is seeing. 230 amps. 239 amps currently being delivered. The peak it ever saw was 279, and it's 198 kilowatts. The peak it saw was 231.
Okay, well, I think we got to get the car in we got to max this out on another video where
Yeah, hey.
Well, we got to find out what the fastest charging car is. The fastest I
Yeah,
can think of is Hummer EV, 365. But that's so funny to think about because like this can do double that and it's not even trying. I mean, we already showed your other charger, the big one can do 1.2 megawatts
Yes.
easy. So like chargers are so far ahead of the cars.
The chicken and egg problem. You know
Yeah.
how we solve that problem? That's why we make our own batteries here. The whole thing, the whole focus is the foundation of everything. And so there's a lot of talk about all the different vehicles on the market, but it starts with the foundation. And what is that foundation? It is the batteries. And so the key here, this is what, a 1C, 2C rate battery pack?
Yeah,
Well,
not much.
what we're focused on here is 5 to 6 C rate of charge
Sure.
to discharge, and the ability to charge 500 miles in under 15 minutes. If you look at our old YouTube videos, we've charged it in under 8 minutes, 7 minutes and some change.
Right.
And so that's our goal here, is to kind of unlock what I call the plasma TV stage into the LCD.
Yeah,
they were
nice.
heavy, they were expensive, they
Yeah.
were hard to get, and now LCD 50-inch TV you get for like $200.
No, I know. What's really happening here from a charging perspective will actually enable automakers to build crazier stuff.
No one's doing it though.
That's the hard part to imagine. And what's crazy is it's not because of customer demand. No one is ever saying, I want charging to take longer. Everyone's like, I just want to zap up and go.
Yeah, but there's also a cost associated with it. Like in the
course.
particular example, the initial entry point to own an EV was expensive, especially Lucid Air is kind of
Yep.
a high entry point, but you get 500 miles off of it, so you
Yep.
pay for it. But we're at that plateau mark, that point at which batteries are starting to get a lot cheaper. They're going to become commonplace. I mean, especially with all the different tax breaks that are happening on the EVs.
Totally.
And you're going to start seeing higher powered batteries. There's already research going on into new chemistries.
Yeah.
Research going on solid states, for example, silicon anodes, just all around different sourcing for energy. Same thing for motors. Motors are becoming more powerful.
Yep.
You're starting to see axial flux motors,
Yes.
carbon fiber wrapped motors. And then same thing, you're starting to see a lot of new standards come out. I mentioned this prior, so I myself sit on the SEJ 3271 committee, as well as the CHAR and MCS committee. And so we already have the industry looking into megawatt charging. But that is primarily focused for medium heavy duty market because they have bigger battery
Sure.
packs. But it will be accessible for the consumer market and kind of the light duty market. But it is up to the OEMs to be able to want to adopt that technology.
Of course, yeah. And so that, like you said, chicken and egg will come. Back to today's project, which is
Yes.
really invite as many cars as you can to do interoperability testing. How do you data log that? What's that all like?
So everything is connected to the cloud. I mentioned it earlier, and as you saw on the website, all the information that's vehicle is communicating with the charger is being data logged in the cloud in terms of its power, amperage, even the temperatures inside the container throughout various points. And so the purpose of that is for us to understand the vehicle performance and then do a data chart. And then what we want to reveal to the world is the different type of vehicles and what their limitations are. Like, for example, we had a few people say, oh, my vehicle can't take 700 kilowatts. That's not the point. The point
Right.
is we're capable of delivering that amount of power, not necessarily that's what the vehicle can take.
Sure.
So we want to reveal to the world, here's a Lucid Air, and this is the performance of it, not
Right.
restricted by the charger. It can deliver this amount of current on
And
this
will
amount
you
of
make
time.
that public?
We are going to make that public.
So
Yep.
pull a Fastned situation.
Possibly.
Yeah,
And
that'd
that's
be
something
awesome.
that's like a lot of people you said it yourself. What is the fastest EV on the market? And why is that such a difficult question to answer?
Right, you just need you know how long it takes me to get all this data when we test cars? It's like, oh, that was a bad charging session. Let me go spend a whole day draining that car.
How do you know it was
Try
the
again.
car and not the charger?
Of course.
Like, it's
Yeah.
hard to tell.
Yes.
We want to reveal. We are about transparency, so we're going to show that information.
I love it. That's
and
so sick.
It's all accessible to
And
everybody.
today's like the ultimate stress test for the charger because it's almost 100 degrees. This thing's in bright sunshine baking.
And it's painted black. Who would
Yeah.
That's the brand.
And-
but it's cool to the touch.
It's crazy that like you're just,
not just that, even
constantly
this.
charging electric cars.
Well, the sun is making it hot. You want to touch it in the
yeah,
street?
yeah, sure.
The
Well,
sun
that's
is
not even
making
that
it-
hot. This is pretty much cool.
Yeah.
Yeah, that's amazing. So can you tell me about this cable and what's going on here?
Yes. So we have a partner currently on the CCS cable, but it's very similar to the technology we've demonstrated on the Atlas cable.
Okay, yeah.
So this particular cable is immersion cooled based technology. So it's not released out in the public yet. This is
So
strictly.
this one's a prototype.
This
cable
one's prototype.
From a supplier.
And in the combination of the work that we're doing with this provider is we are stress testing that cable on the most powerful vehicle.
Oh,
so
very
they
cool.
do laboratory testing. We're doing real
You're
world
doing
testing.
real world
And
testing.
so the intention here is pair the most powerful handle with the most powerful charger.
I love it. That's cool. When companies are coming to you to stress test their components, that's
and
neat.
Our focus is to be partners in the industry.
Yeah.
And then the unfortunate thing is the reason formerly what we called AAC, maybe we'll call it NAC,
Sure.
the new advanced charger.
Yep.
And the reason why we designed that particular charger with the 4 ports on it is because there is no standard or charging handle that exists
Right.
for that amount of AC power
Right.
combined with DC power.
Right.
Still an option available, but the whole point is it's universal access. This will be MCS compatible, CCS compatible, NAC
I
compatible.
mean, you could really just put whatever cables you want on this.
Doesn't
thing.
matter.
Yeah, that's so
I mean, we're
cool.
debating. Chatham?
No,
No?
no.
Got to leave some room for the Nissans.
I mean, I own a Leaf. It would be nice.
It would be
but
nice.
we're like, I wouldn't even focus
Maybe.
on the past.
Oh, well, think about it.
Okay.
The whole point
But
is
if you
it's-
do, make it a 100 kilowatt Chatamo.
Listen, it'll push. Well, finding those cables,
Yeah,
but
sure, yeah.
this will give whatever the vehicle wants.
Yeah,
That's
maybe
not
you
gonna
could
be
come up with like a liquid cooled CHAdeMO thing. You know what would be cool for you guys to work on, totally separate from the rest of the new stuff, is come up with a CHAdeMO to CCS adapter. Or
No.
CCS to CHAdeMO.
No,
And sell
no
it to
doubt.
Leaf owners.
No doubt.
Well, this is really freaking cool. Immersion cable technology, immersion cooling is something that's
The future.
really hitting the market. Version 4 superchargers are already having that over in Europe, we've seen. So this is all awesome. And congratulations on being able to demonstrate this
Yeah, I
so
love it.
quickly, by the way, because we only saw you a few weeks ago.
Was it a few weeks? Feels a lot
Yeah,
long.
maybe
So
a
you're
couple
saying we
months, yeah.
built this in like a week or something? That's how quickly we built this.
Amazing.
I wonder what we're gonna do next week. Like,
Yeah, that's crazy.
you gotta watch our videos.
Yeah, well, yep. So we'll
You
leave
link
a
on
link
YouTube.
to the YouTube channel in the description. I want to go inside and see what else you have on display. I hope you don't mind. I'm going to juice this up to like 95%.
Yeah, yeah.
So I can skip Quartzsite and all the other chargers back to LA.
Yeah, you
So
absolutely.
we'll let
or
this
just
thing.
trailer this behind you. No, I'm
Yeah,
kidding.
well, I'd love
If
to
you
do
could.
that one day. But we'll juice this up to 100%. You know, just works. You plug in, you hit a button. Will you have ISO 15118 plug and charge?
Yes, we will.
Okay, so
Yep.
you know, if your car is capable, you'll sign up through your website, I imagine, and then you just roll up to a new charger, plug it in, walk away.
Yeah, and the benefit is the bidirectional capability. So
Because
we
I
talked about
have
that.
you as an expert, this is a question that we debate a lot. By the way, Rivian Amazon van.
Hey,
Let's plug it in.
yeah, you think they would let us?
Yeah, go.
Hey,
let's
you
go
go,
talk
go
to him.
ask.
Let's just go talk to him.
That's all you.
Yeah, we already got someone running to go talk to him over here.
Go, go, go.
Yeah. Yeah, can we? Okay, good. He's going to ask if we can plug it in. Yes.
It's an exciting day here at you.
Okay, well, things are happening. We'll see. Okay, while we're waiting for this, ISO 15118
Yes,
plug and
yes.
charge or MAC address activation,
So
from your expert opinion.
behind the scenes. So the issue with MAC address is the user experience. It's easy to spoof MAC address.
Sure.
And
But
so,
is it easy on the car to spoof MAC address?
well, yes. Well, if you know what you're doing, it is.
Well, for
And so-
you, you're a nerd, but yes.
I know how to do it.
Yeah.
And so the issue is, like, you could allow the free charging on if the MAC address is approved, and then you can blacklist it, but then you can keep changing it. The ISO 15118 is the standard that a majority of companies are going towards.
That's going to be
and,
the future.
That's the angle. So it's between like USB-C and Lightning. And so
Yeah.
you see already Apple switching to USB-C.
Sure.
And that's the direction that the industry is going.
Okay.
We are supporting all industries, but we are not against being able to utilize other standards if they come up. But for us, it's about the experience. And if
Yeah.
we have to create our own experience to improve that, we will.
Okay, well, no, good to hear that background there. Let's see if this Rivian dude allows us to charge his van. We've never done a Rivian charging log.
No?
but
Well,
those, are
clearly-
those are the cool things that you can do if you deploy this in the public. You
Yes.
can like get all the weird cars, like Rimac Navara driving to LA.
Yes.
Oh, crazy.
And one thing I'm curious to talk about. I guess your users, users, your viewers,
Yeah.
can put it in the comments. Now, the idea of vehicle to grid. I'm curious your thoughts. Like, if vehicles were able to put on their energy back on the grid, do you think there's any application in that?
Yeah, but not on a fast charger.
Well, yeah.
Yeah, because you want to get out.
Yeah, you're
But
that's a
yeah,
good
of
point.
course, like if you're just like, if the car's parked, my viewpoint is if I can earn money from utilizing the energy storage that I purchased to help offset the purchase of the vehicle, why wouldn't I do that?
That's a good application.
Yeah.
I like that. I feel less applications for the particular consumer. One, it affects your cycle count on the battery.
Of
Two,
course.
let's say, hey, oh crap, I gotta go. My wife's pregnant, hospital run. Oh
And you're
crap,
out.
I drained my battery.
I get it.
So
But
I'm
if you have a Lucid Air with 500 miles of range and
You could-
everything you need to do in your city is, you know, within 50 miles,
Yes.
you can say just don't discharge it below 20%.
That's very solid. I like.
But I really don't. The thing is, we've talked about vehicle to grid since the late 90s, with like even the T0 had a vehicle to grid thing. And we were just over at the Peterson Museum. They had two T0s, and they're like, vehicle to grid tech. It's just like, hasn't happened, probably won't happen.
And it's going to happen.
You think so?
I know so.
Well, I
know.
hope, because it would be so cool. But we've not seen anyone tie these pieces together yet.
We're building it.
Oh,
Yep.
great. Okay,
Yeah.
well, that solves that then. I knew we found a great like partnership with you guys because like everything I'm curious about, you're already working on.
I mean, I've been in the industry for like since the beginning. Yeah,
Yeah.
I might look young, but like pretty much 5 years old. Here I am taking apart. I wasn't not 5 feet.
Yeah.
I'll tell you, my grandfather owned a body shop. So I'm an electrical engineer, but and my wife's a mechanical engineer. And ever since I was young, I used to love taking apart stuff. And my grandfather owned a body shop, and I used to love working on cars. My uncle owned an electronic shop, so I loved working on tools and stuff. My father was a civil engineer, and so I have all the aspects of engineering. So when I see stuff like this, I nerd out.
Yeah.
I enjoy it.
And that's all of our viewers too. We love this stuff. So let's see if we can get the Rivian dude.
I guess not.
I guess.
He might swing back around.
Oh, might swing back around. Okay. Well, we're coming out if that happens. But let's run inside and see what else is going on. Well, you joined me over inside the new building now with Andrew. How's it going, sir?
Good. How are you?
Hey, thanks for having us. And we're in here to talk about batteries, discharging, but also charging.
Absolutely.
And what we talked about outside that charging station having 700 kilowatts, and like you could do more, and we've shown more. We've shown 1.2.
Yeah, we got another one over there, right?
Yeah, and that one's really juicy.
Yeah.
But what we haven't talked about is like what cars will be able to accept this. How is that even possible?
Yeah.
So you guys are also not only building charging equipment, but your own cell technology.
Yeah, right over there.
Yeah, literally pan over this way, you'll see right in here you have a dry room, which is crazy.
We got another one coming here soon too.
Amazing.
Actually here. It's
Oh,
not
really?
built yet. Yeah.
Cool.
Absolutely.
So I've heard about the Cube cells.
Yeah.
I don't know much about it. We've taken our audience on a full tour and did like the high level stuff.
Cool.
What I'd be really curious to know is like what makes this able to accept a charge so much faster than other cells?
Yeah, so it's really, it really has to do with the shape of the electrodes. So if you're familiar with like a 4680,
Sure.
they call it the, what do they call that? The infinite electrode.
Oh, sure.
So
Right.
essentially,
Yep.
so essentially these are full electrodes. So across the whole terminal here is the electrode. So this one's not welded, but you would normally see all the welds in here. So every one of those electrodes is electrically connected to this on both sides, right? So,
Okay.
so this shape is quite unique. Like nobody makes a cube that I
Right.
know of, but it allows you to package them efficiently. But the most important thing is actually we can heat and cool this very quickly. The internal resistance is super low. So what that allows you to do is actually pump a lot of power in there and not create a lot of heat.
Well, and that's the big thing, right? Is like we always see when we're DC fast charging cars, especially like we have the Lucid charging there, and we noticed an early D rate, and we're like, oh, pack's too hot.
Yeah.
So
How high did you guys hit?
charging power was like mid to high 200s, somewhere around there, but we've seen mid 300s on that car.
Okay, cool.
Actually pulled in with too warm of a battery.
Sure.
So what do you think about like the cooling systems before we even get into the cell cooling?
Yeah.
Like you're gonna need a juicy AC compressor.
Yeah, so I'm actually glad you touched on that because sitting behind you is some of the heating and cooling stuff here.
Oh yeah.
This is actually not for the 30 kilowatt hour pack.
Okay.
This is actually a cooling plate for around a 70 kilowatt hour pack. It's very specific to a customer.
Okay.
But this system, 60 kilowatt battery pack usable, we're
Yeah.
pumping 30 kilowatts of cooling into it.
Oh wow, crazy.
But heating, we're putting 60.
So you're doing 60 kilowatt rapid heating. So like for example, a Hummer EV we've tested, we've like maxed out the heater at 12 kilowatts, and that's cabin plus battery.
Yeah.
Like a Model 3 will do 7.5 kilowatts battery heating with the afterburners on, with the motors, and maybe 8 kilowatts if you add the heat pump to it. You're talking 50, 60 kilowatt battery heating in terms of power output on a pack that's 60 kilowatt hours in storage.
Yeah, so the main thing is like, you don't want the battery to be hot for a long time. So we're actually taking and heating that cell up in 120 seconds.
Wow.
So that's how we bring it up. When you bring up the heat of the cell, you're actually reducing the internal resistance of the cell.
Of course.
So it's I squared R. So the lower the resistance, because we can't change the current.
Right.
We want to put in that 5C, so the resistance has to go down. So that's why cell design is important. The heating, this is actually a heater for one of our battery packs.
Oh, this right here?
Yeah, so this goes actually right onto the module itself.
Oh, very cool.
So that's actually goes into this platform here. So this is a pouch cell module here, all the same technology. Someone bent this one here, but this is not a live cell, but you can see like the tabs are, full length electrodes.
That's crazy, yeah.
The terminals are way thicker than you'd see on a normal pouch cell, and they're full length. So normally you would have two just sticking out the top or the ends.
Right.
And they're very thin.
Yes.
So that's like you know, like if you wanted to put all this water out of like a fire hose, but you had a little hole at the end,
Right, of course.
So it's the same thing here. We had to come up with terminals that would be able to pass the current through it, low resistance, and then be able to heat and cool it very efficiently.
Right.
So that's some of the challenges when we were making this, because you got to heat seal these things, and all that heat was being soaked through like a heat sink.
So pretty amazing that you're going to basically control the pack temperature, and you're absolutely right. I mean, for any of our viewers, a lot of them own Tesla vehicles. We've seen, you know, you DC fast charge them at a supercharger, the pack might hit, you know, 64, 65 degrees C on the hottest cell. As soon as you unplug, that car's ripping cooling as hard as it can.
Absolutely.
Because it's just like, zzz, and you know, it's trying to cool everything down. Some electric cars don't, and then you're like, I have limited performance afterwards.
Absolutely.
And like it gets crazy. But you know, definitely we know for sure Tesla kind of sets the benchmark for today's technology of thermal management. And so just the fact that they're unplugging, when you unplug from a supercharging session and it rips cooling, and you're kind of saying the same thing, but like way more cooling and way more heating. It makes sense to me. It sounds cool.
Yeah, when you're pushing 5C, right? And you don't want to keep the cells hot for a long time.
Right.
So what that does is it degrades the cell life.
Yeah.
So if you want to get a lot of cycles out of the cell, you have to keep it at a temperature that it's comfortable. So if you're pulling up to a supercharger and your batteries are already hot, they've been hot for 30, 40 minutes because they know you're going to a supercharger.
Right.
So that does degrade the performance of that
You
cell.
want to basically plug in, rip heating right then, take the extra power from the charger, and then when you're done charging, rip cooling, and then you're good to go.
Yeah, because then you'll be able to pull out in your drive. Your batteries are back at 30 degrees Celsius. They can maintain that. They can live there. They can be happy. You can't see it because it's roped off today, but we have our own thermal management system we designed ourselves.
Oh, cool.
So that has, we call it a T-board, and that controls basically everything inside that coolant system. So it's a refrigerant cooling. In this pack, we use water glycol. Previously, we did have an immersion cool pack.
Wow.
We're moving a little bit away from that because there's a lot of challenges there. Basically, it's a lot of mass.
Yeah, I mean, there's so much thermal mass that you
Yeah.
just takes so much energy. And what about the gradient temperatures when you do that inside the cell?
Yeah, so this was designed to have a 2-degree delta C across the terminals.
Really?
And that's why it's this short.
Okay.
So the distance between the two, the very long tabs like we're talking about here on the pouch cell, this is super important. Like as you grow bigger, that gradient is very large across it.
Yeah.
And one thing that we didn't talk about is the current is uniform across this, which is super important too. If you had a current density, it looks like a horseshoe.
Yeah.
So the cell degrades kind of like that too. And also the heating profile would match that.
And if you're talking about 5C charging, what about lithium plating?
Yeah, so that's why it's really important to heat it up, right? So when you have a very cold battery pack, it's like that.
And it's almost irreversible unless you shock the hell out of it, right?
So we do have some things that we can do that, but it's not out yet.
Okay.
But yeah, so normally lithium plating happens if you have high internal resistance.
Right.
You have a very cold pack.
Right.
So that's why when you go to the superchargers, you're heating up the pack. You're lowering the ionic resistance of the cell. So it allows you to pump energy in. Yeah.
And we've done experiments where we've taken our Model 3 to a supercharger, for example, and plugged it in, let it sit at minus 20, minus 30 degrees Fahrenheit, and it takes 45 minutes for it to even start charging.
Absolutely.
Because it's just trying to get the coldest part of the pack warm before it throws electricity at it.
Yeah, so did you trailer it there so it'd be cold?
We left it there.
Okay, cool. Yeah, I was gonna say, otherwise you can't get that experience, right?
Yeah, we parked it right next to a supercharger, literally like minus 28 or 29 F.
Yeah.
And just backed it to a supercharger, plugged it in, and nothing happened.
Yeah, so that's one of the importance of having the heaters in there too, right?
Yeah.
So we played around with having inline heaters, sort of like GM does in some of their packs.
Yeah.
Or doing resistive heaters. And it really is dependent on the system, right? But this will directly heat the cell. Directly heat it. So we go from, let's say, 25 degrees to 55 degrees, 60 degrees in 120 seconds.
That's crazy.
So you wouldn't be sitting there very long. You'd plug it in. You'd obviously use quite a bit of energy.
But you could pull that from the charger.
Yeah, you'd be pulling it from the charger. And you're bringing that pack up. And now you're being able to bring it up even further to be able to charge very quickly.
So where will we see this cell technology go? You know, we started the video off over at the charger outside. We mentioned we might see a pack almost as big as a megawatt hour in there. We'll see what happens.
Yeah.
But will these cells power that charger?
Yeah, absolutely. So I think down the road you'll see some different chemistries too. We got a bunch of chemistries that are going on.
Okay.
So when you get into like grid and charging applications, you don't normally need to pull that 5C, or you're looking for a long cycle life. So that's more of like an LFP chemistry.
Yeah.
But we're able to do that with the NMC that we're using in these cells as well.
Okay.
So if you actually look behind you, this is one of the packs that's going into the megawatt charger.
Oh,
so
cool.
this is 30 kilowatt usable. So it requires about 33 of those to power that, and that's super dependent on your grid power, right?
So what's the gross capacity of this? Like 38 kilowatt hours?
Yeah, 37.5.
Okay. Yeah.
So we top or lower 10, top 10. We
So
cut off
10% buffers.
Yeah.
And what's the reason? Because that's a fairly extreme buffer in the industry.
Yeah, so it's really important for the cycle life of that cell. So we're trying to push the boundaries of that cell already, right?
Yeah.
So we don't, if you looked at a voltage curve in NMC, it spikes really fast after 4.2,
Yep.
and it spikes really quickly at around 2.8.
Yeah.
So if you go on that, either side of those, you're actually causing damage to the cell.
Interesting.
So what
and
we
we've
do is
seen that when we
buffer it.
run cars to zero, we're at 300 volts, we're at 270, we're at 240. Like, yeah, plug it in.
It goes very quick.
Yeah, yeah.
So by taking the battery management system and saying this is not usable, you're actually extending the life of the battery as well.
Oh,
So,
very interesting.
Yeah.
Very cool. Well, thank you for this, and I can't wait to see these in deployment. Obviously, you'll have customers purchasing the cells and
Yeah.
doing whatever they want to do with them.
Yeah.
You're going to be using them for internal projects, and can't wait to see what happens with the charger. I think LFP is perfect for the charger.
Yeah.
So that'll be neat to see how that plays out. But thanks for the taste on all of this and the rapid heating and cooling. I can't wait to do some demos of that.
Yeah, you'll have to come back maybe this summer. So
Yeah.
We have some of these that are going to be built up with this large cooling system, heating
Oh, great.
system. And we're pretty close to testing that out right now.
I want to put them in a freezer, pull them out,
Yeah,
rapid
rapidly
heat them,
heat 'em.
and charge them as fast as possible.
Yeah,
So,
we'll be doing that pretty soon. So
awesome. Well,
come back.
thank you, sir. Appreciate
Yeah,
it. That was
absolutely.
great. Well, there you go. I want to say a huge thank you to New and congratulations to them for the rebrand and also hosting this event for investors and electric vehicle enthusiasts to come by and literally torture test the charger. This is early stage prototype of a unit that you will see out in the public. I was talking to some of the guys here as well. Victor was saying, maybe potentially sooner than you think, we might see similar to like FastNed charging parks, canopy, pull through, data logging as well. They're going to be super community focused, share charging logs of stuff. And, we all love the FastNed transparency in Europe with that network. I think we'll see something similar here. That's the impression that I'm getting. But just so cool for them to say, hey, we got this new charger. We need to test it on a whole bunch of cars. Why don't you just bring what you got? Come hang out. We'll have a little party, show you our cells, show you everything that's going on. And it's just really cool. This thing's just ran flat out all day in the baking heat, no complaints, no issues, still outputting full power. My friend Ben from the Jeebs YouTube channel is on his way over here with a dead Model Y. We're going to zap that up as well. And I'm just going up to 100% charge on the Lucid so I can make it back to LA without stopping. That video will be on Out of Spec Motoring. But again, a huge thanks and congratulations to New for having us. We'll see you on another video soon. Bye-bye.